So in the first short note lecture we covered this page. I hope you have seen that video. Okay. Now very quickly I will now increase the speed so that we save. So here what I did after the introduction, what as a short note we can write is different concept at very high level we can put. So those are abstraction, encapsulation, generalization and polymorphism. And what are the elements needed for object oriented software development? So these are the list of elements needed. So while writing the notes, what you can do, you can make this complete list like this, and then if some more information is there you can add. I have left the space here, but you can always write there what is use case. Use case is the one of type of diagram which says that how user is going to use the system, right? Role means the person who is going to use the system, what is the role of that. So all these things I have written over here to make things more simpler, and while you are reading also it would be easier to remember the things. Now what are the benefits of a standardized language or framework or something? So these are some of the benefits I have mentioned, which talks about precise definition, easy communication. Easy communication means because you are using a common language, so everyone knows that what is the use case diagram, what is the network diagram, what is the interaction diagram and all that. Then training is widely available, encourages automation and enables early verification and validation. Early verification and validation means you have those diagrams ready. Those diagrams can be used to develop software, and earlier verification and validation can be done through review and testing. Now UML has some more connotation which I'll explain. That U means unification of object oriented method, M means analyzing requirement and designing objects prior to coding, and L is set of graphical language, unified modeling language. This is what the brief definition is. Now how UML started, what is the root, what is the origins of unified modeling language? One is this Bush method, Jacobson object oriented system engineering, OOSE, or software engineering. Then there is Rombach object method technique, OMT I think, but I will reconfirm. Then Mayer's design of the contract. So these are some of the origin of unified modeling language. Means these are some of the basics or base used to create unified modeling language. Now what is OMG? Not oh my god, this is object management group. I think this was a group of people or some organization group which standardized the unified modeling language. There are few more concepts, but I will not talk about those, core by the object, common object request broker architecture, and all these things are there. So I will not talk about. XML is extensible markup language, right? So all these things are there. I will not talk about that. Now UML models are being developed using or through use cases as I mentioned earlier, package and classes, sequence, collaboration, activity, state, component, process and all that, and deployment also. So while you are writing it in such a way that it is easily readable, and try to ensure that you write always in a good handwriting. Okay, this is what I want you to imbibe and learn while you are preparing your own notes. Okay, now coming to this, what UML is not. So UML is not transferable, textual and fixed. It is not a process. It is a modeling language. It's not a process. Now one more basic question before we go ahead with the unified modeling language details. We should know what is the developmental process. Developmental process is a set of standardized, agreed upon, order and repeatable activities, optionally of a group of people, resulting in the exact needed goal. The goal is a working software consistent with all its requirement, executing exactly as specified, completed on time and on budget. So there are many more things which are there. So here we are just trying to learn the basic of unified modeling language, but I am trying to give you some background information or some contextual information also here about development methodology. And then comes life cycle model. So life cycle model is what? It's ways to describe the flow of developmental process. This is very important. This part, development process, is very important, because when you develop something in software, there are various stages requirement to design to coding and testing, all that. And those life cycle models, generally I am saying there are few more, but I have put only two here. One is waterfall model and second is iterative model, or sometimes it is called incremental also. Waterfall model is called the classical one, and this is called new approach or something we can call it. Why it is called waterfall, maybe I'll cover this in some other video or lecture, but in brief I have shown the diagram here. So if you see, waterfall life cycle model: requirement analysis and design, coding, testing, product and maintenance also. So here you can write like this. You can see this is looking like a waterfall, water flowing from requirement, design, coding, testing, product, and this is the final outcome. Here you can write what design consists of, coding, testing and all that. Coding or testing also way called verification, validation. There is unit testing, integration testing, system testing, user acceptance testing, regression testing. Many things are there. Okay, so I will cover those things in other video. Now coming to the iterative life cycle. Iterative life cycle model is where you continuously refine your requirement, design, coding, testing. Requirement, design, coding, testing. This is how it goes every time. So it starts from the initial requirement, your design is, code is, and then every iteration you will add some new feature, new requirements. Every time there will be some change, some new addition, new feature. That's why it is called iterative. Okay, maintenance request also comes in between when you are adding more and more requirements. So if you really read this thoroughly, this is my initial requirement. So when I say initial requirement, so okay, I want these 5 features to be implemented in this software. Okay, you come means developer will design it, code, test, and now this is iteration 1. Iteration 2, what we said, 5 requirement. Here you added 2 more, so it will change to 5 plus 2, now 7 requirement. Then next iteration 3 more added, so it will change to 10 requirements which are to be implemented. Now maintenance requests also come between some changes are there or some maintenance requests. All these things are also there which we can use. Now some pros and cons are there. What are the pros and cons? So pros are reduced complexity, allows requirement changes, you can produce running and deliver early, because it's iterative and you are taking some set of initial requirement, design, coding, testing you are doing, you are adding more. Now cons means disadvantage is sometimes become harder to control manage, because continuously you are changing, you are iterating, you are changing, iterating, changing. Sometimes your maintenance, your time, development, everything will go for a toss because there is no control. So but nowadays there are various tools available, automated tools are there. You can have the complete control on requirement on continuous basis. So end to end workflow would be there using. So for requirement there will be one tool, design there would be another tool, coding another tool, testing another tool, or like that. So even this disadvantages there can also be managed and controlled through those tools. Maybe I'll cover those tool set also in some other uh, lecture. But okay, in brief I can tell you, For requirement, there is doors is one of the tool. Design, there is rational design software is there. Rational is product of IBM, which is being used, for designing of software. So how it works is, you feed your requirement in the requirement tool called doors or something. You use the rational design tool, rational rows or something. Draw your all these diagrams, like your use case diagram, interaction diagram, into this. It will convert that into code in using some IDE. Then you can conduct testing. Also, there are some test manager and other tools are there. Those can be used for unit testing, integration testing, system testing. All those tools are also there. Now, like, you have the complete tool set, 1 2 3 4, all tool sets are there. And for maintenance, some change management software also will be there. I know some rational, that clear quest or something there, which is used for configuration management, and few more tool set are there. Maybe I'll talk in some other session. Now, any software development which you do, it has a starting point is what? Starting point is your requirement. So what, I'll stop here, because I think this is the logical end of the basic concept. I will start in the next lecture, set number 3, on nodes and UML. I'll start with the requirement specification. Thanks for watching. All the best.